let's revise index numbers, guys. The first thing that I told you beta is that index numbers as such, guys, is a relative value as such, guys, which is comparing data over multiple time periods, guys, or over multiple geographical locations. The intent as such, guys, is to convert those absolute values into relative values so that the relative values as such beta can be compared. The common type of index numbers that we see as such beta is for the stock markets, you have Nifty and Sensex, guys, is there so. Then there is wholesale price index or consumer price index. All of these beta are where absolute values are converted as such, guys, into relative values. So for construction of index numbers as such, guys, especially when it is related to multiple time periods, normally we deal with multiple time periods only. There's always a base period that is selected in comparison to which, guys, all the other values will be stated. The value for the base period as such, guys, for the purpose of comparison will be equated to 100. Correct, beta Chirag? Whatever is the base year, the value of that year will be equated to 100. Now, as far as index numbers are concerned, guys, first, before constructing index numbers for a group of commodities, you've learned the concept of a relative. The word relative is used, guys, when you compute an index number for a single commodity. It can either be price relative, it can be a quantity relative, or it can be a value relative. If it is price relative, you will talk about you will compute it as price of the current year divided by price of the base year multiplied by 100. If it is quantity relative, it will still be quantity of the current year divided by quantity of the base year into 100. Same way, value relative. As long as the calculations are being made for 1 year, you will use the word relative. All right. Under relatives, we also did the concept of chain relatives, guys, and link relatives. Chain relatives as such, guys, are what? When the relatives are computed, guys, with respect to a fixed base as such, guys, it will be called as a chain relative. When the relatives are computed in comparison to the previous year, it will be called as a link relative. In relation to previous year, it is link relative. In relation to base year, it will be. So if I'm computing chain relative for the year 2025 with 2020 as the base, it will be 2025 divided by 2020 into 100. If I'm computing link relative for the year 2025, it will be 2025 ka value divided by 2024 ka value into 100. The same MCQ came in the last attempt also. How to compute chain relative for the current year using chain relative of the previous year and link relative of the formula options directly. So chain relative for the current year is equal to chain relative of previous year multiplied by link relative of current year divided by 100. This is how you do it. Now, after this beta, we moved on to index numbers, which is basically computed for a group of commodities collectively. अब ये group of commodities के लिए बेटा I said index numbers will be broadly classified into two categories. It will be simple index numbers and weighted index numbers, simple or unweighted index numbers. Under each of them, there will again be two categories, aggregative and average of relatives. So we have four broad categories: simple aggregative, simple average of relatives, weighted aggregative, weighted average of relatives. Under simple aggregative index number, all you have to do beta is add up the prices of the current year divided by all the prices of the base year. Summation Pn divided by summation P naught into 100. That is how you're going to arrive at simple aggregative index number. The biggest drawback of simple aggregative index number beta is that it will be affected by a change in unit of measurement. Instead of taking price of 1 gram, if I take price of 1 kg, automatically the index number is going to change. Next beta, though there are no weights assigned, the product with a higher price automatically will have a higher influence on the overall index number. Are we clear about this? This was the drawback as such beta of simple aggregative. Now, this is where we moved on to the next method, that was simple average of price relatives. What you do here beta is you first compute relative of each commodity, then you take an average of that. By default, the word average would mean arithmetic mean or geometric mean. Very good. It means arithmetic mean. You compute price relative for each commodity and then you arrive at the arithmetic mean of those price relatives. समझ में आ रहा है नहीं आ रहा है बेटा? What will be more suitable as such, guys? Geometric mean. What is more practically used? Arithmetic mean. ये भी MCQ में आया था पीछे. So as of now, as such, beta, you're supposed to take an arithmetic mean of all of those price relatives. By computing price relatives, you are removing the impact of the unit of measurement. It doesn't matter whether you're taking price per gram or price per kg, you're anyways going to get the same price relative. So that is why you first compute price relatives, then you take an average of those price relatives. What is the other drawback that still remains? Weights. Because you're taking a simple average of all of these relatives as such, guys, you are indirectly giving a equal weight as such, guys, to all of these commodities. In real life, the weightages as such, beta, need not be equal. जब सेंसेक्स और निफ्टी की बात कर रहा था बेटा मैं, वहां पे weights assigned है क्या? But the company with the highest market value, beta, indirectly has a higher impact as such, guys, on the overall change in index number. Are we clear about this? After that, beta, we moved on to weighted aggregative. Under weighted aggregative, the formula, beta, is summation Pn into weight divided by summation P naught into weight divided into 100, guys. Usually when you're computing price index numbers, weights will be quantities. Now, depending on what quantity are we considering as such, beta, there are multiple index numbers under weighted aggregative. The first one, beta, fast one कहते हैं. ये जो वही last pairs में ला है ना, तो यहाँ पे when you think about the second word, guys, हाँ जाने दो. The first one, guys, is last pairs method. What do you do under last pairs method, guys? You take base year quantities as the weights. So that is why the formula will be summation Pn Q naught divided by summation P naught Q naught into 100. Under Pasche's index number, beta, it is summation Pn Q. And current year quantities, beta, are taken as weight. So that is summation Pn Qn divided by summation P naught Qn into 100. Marshall Edgeworth mein, guys, you will be taking both current year as well as base year quantities as weights. So that will be Q naught plus Qn into Pn divided by P naught into Q naught plus Qn. Apart from this, beta, there was also Fisher's ideal index number and Bowley's index number. Fisher's index number is the geometric mean of L and P, and Bowley's index number, beta, is arithmetic mean of L and P. You can also compute weighted aggregative as such, guys, with fixed weights. Doesn't depend on base year quantities, doesn't depend on current year quantities. Some random quantity as such, beta, will be considered as the weights for construction of weighted aggregative. Are we clear about this? The advantage of weighted aggregative, beta, is that because the quantities are being considered as weights, it will no longer be affected by change in unit of measurement. This is the reason, guys, why unit test later that we study will be satisfied by all the index numbers except simple aggregative. Baki sab ke sab, beta, will satisfy unit test. Weighted aggregative, though we are directly taking absolute prices, it still satisfies unit test. Why? You are multiplying prices by quantities. If you take price per kg, you will multiply by quantity in kg. If you take price per gram, you will multiply by quantity in grams. The product is still going to remain same. The last category that we had, beta, here is weighted average of price relatives. You still compute price relatives, guys? Weighted aggregative of price relatives, yaad hai nahi hai? Weighted average of price relatives, beta. You compute price relative for each commodity as such, beta, and then instead of taking a simple average, you are going to take weighted average of those price relatives. इसके बारे में कुछ ज़्यादा था नहीं, beta. Are we clear about this? After this, same concept of chain index numbers, guys, and link index number. Earlier it was in relation to one commodity. That is why the word was chain relative and link relative. Now it is in respect of group of commodities, guys. Hence, instead of using the word relative, beta, they're going to use the word index number. Are we clear? Quantity index number ke liye, beta, it is exactly the same as price index number, just that except quantity being the variable, guys, you will now take price as, instead of taking price as the variable, guys, you will take quantity as the variable. And if quantities are being considered as variable, the weights should be prices. So जो भी formulas पहले पढ़े, बेटा, उल्टा लेना. In place of prices, you will take quantities. In place of quantities, you will take prices. Be careful in the examination whether the requirement is to compute price index number or quantity index number. All right. If they do not specify anything, it is always and always price index number. You will have to compute quantity index number only if it is specified in the question. Value index number ke liye, beta, you do not have multiple methods, because value ke liye you will directly have to take current year value divided by base year value. So the formula is standard summation Pn Qn divided by summation P naught Q naught into 100. After this beta we spoke about the usefulness of index numbers. उसके बाद में deflating में आए. Usefulness of index numbers में beta you can use that for the purpose of framing your business policies or government policies, because once you compute this index number you're going to identify the trend as such guys, or by how much is the value going to increase by. Can we use all of that beta for estimating our business variables guys? Yes. We use that for deflating data. We use that to identify seasonal fluctuations. Yeah, the secular trend, cyclical forces, seasonal fluctuations and noises. Again, theory question cannot come. They can only give an MCQ, but you should still know what is the usefulness of index numbers. Now, moving on to the next point, beta, deflating. Deflating का मतलब होता है converting nominal value into real value. That is removing the impact of inflation. So whenever you're computing real values as such guys, you will have to take current year value divided by the price index of the current year multiplied by 100. याद है नहीं है? By doing this, you're removing the impact of inflation. There are two set of questions that can come based on this, guys. Either they will ask us what is the additional wages to be given to compensate for reduction in the purchasing power. If they do this, what should you compute? Current year value. You will ignore the value that is given in the current year, pick up the base year value, inflate it, and then see what should be your wages in the current year. Those wages as such guys you will compare with the actual wage that you're getting in the current year, and the difference will become your increase in wage. If they ask us to compute how much did you gain or lose in real terms, then beta you convert nominal value into real value, base year value, and then compare it with the actual value of the base year. The difference will become your gain or loss in real terms. Gain or loss in real terms, you convert it back into base year value. If they ask us to compute by how much should you be given, what is the additional compensation to be given, you compute, inflate base year value beta into the current year value. इसके बाद में beta, before we did test of adequacy, we also did shifting and splicing of index numbers. Shifting of index numbers beta is basically wherein you change the base. Pretty easy. Whatever is the new base year guys, uska index number should be equated to 100 and all the other values will be computed proportionately. Are you getting it guys? So original price index divided by price index of the year to which the new base is shifted multiplied by 100. This is the formula guys. Splicing of index series matlab combining. You have two different time series, index series data beta with two different base years. You will have to combine them into a common base. Are we clear guys? Finally beta we moved on to test of adequacy. There are four tests beta: unit test, factor reversal test, time reversal test and circular test. Under unit test we will have to check whether the index number guys is getting affected by a change in unit of measurement. Side mein. We will have to check. We will have to check whether the index number as such beta is getting affected or by a change in unit of measurement. So all the index numbers as such beta satisfy unit test except simple aggregative. Are we clear about it? Time reversal test mein guys, if you multiply index number with the current year and the base year interchanged, the product should be equal to 1. P01 into P10 should be equal to 1. Practically you will get the product as 10,000. That literally means 100% of 100, it should be equated to 1. So that is time reversal test. Time reversal test is satisfied by simple aggregative. It is not satisfied by simple average of price relative, but it is satisfied by geometric mean of price relative. क्योंकि जब product आता है बेटा उल्टा भी करोगे ना तो वो strike कर सकते. If you are adding, you will not be able to strike. Following? Simple average of price relatives does not satisfy time reversal test. Geometric mean of price relatives will satisfy time reversal test. After that beta, when it comes to weighted aggregative, Marshall Edgeworth satisfies, Fisher satisfies. Marshall Edgeworth, Fisher and fixed weights. Reason being beta, whether you interchange base year with current year or current year with base year, the weights are going to still remain same. That is the reason why Marshall Edgeworth, Fisher's ideal index number and weighted aggregative with fixed weights will still satisfy time reversal test. Last pairs method, Pache's method will not satisfy time reversal test. Are we all understanding this guys? इसके बाद में बेटा we moved on to factor reversal test. Factor reversal test में बेटा product of price index number and quantity index number should be equal to your value index number. P01 into Q01 is equal to V01. The only index number that satisfies factor reversal test is Fisher's index number. That is why we concluded that Fisher's index number is an ideal index number. इसके बाद में एक test आता है बेटा, which is circular test. Circular test is considered as an extension of time reversal test. P01 into P12 into P20 should be equal to 1, or P01 into P12 should be equal to P02. Perfect. वो तरफ लिख रहे हो, normally write P02, यहाँ पे लेके आ रहे हो, it should be 20 guys, and that should be equal to 1. So that is circular test guys. Simple aggregative, will it satisfy circular test? Definitely yes. Weights ही नहीं है इसके पास, बिंदास बेटा. समझ में आ रहा है नहीं आ रहा है guys? Then बेटा, geometric mean of price relatives will satisfy guys. Weighted aggregative also will satisfy provided the weights are fixed. Fisher's index number will not satisfy. So because there are more than 2 weights involved now, when there are more than 2 weights involved, as beta, Fisher's index number will not satisfy that test. Are we clear about this? This is what you have learned in index numbers guys, but then I told you a lot of practical questions are there towards the end, additional questions which you will have to practice. इसके अलावा बेटा starting में limitations या problems of index numbers में we have learned that there's a selection of the variable or the commodities as such guys. The commodities will have to keep being updated. What is to be included now may not be relevant on a later date. Just I told you example of Nifty as such better. Do they keep revising the 50 companies that are to be included? Yes. Plus for inflation index numbers as such guys, the base period cannot be kept constant. It should be something which is relatively stable as such guys. Plus you should obviously keep updating as such guys as the underlying conditions change. I told you how they revised it from 1981 to 2001 as such better, and then it will again get revised. Are we clear about this? This is all that we have learned better in index numbers. We'll move on to the next one better, which is ये हो गया ना पूरा. Bowley's Bowley's क्या है भाई? ये theoretical distributions. Alright guys, just a little definitions as such guys in probability, and along with that beta theoretical distributions. So the first thing beta is the definition of the word. So under probability guys, probability ka definition is nothing but the chance of occurrence or non-occurrence as such guys of a specific event is called as probability. We did what is experiment. I said experiment as such guys is any act that produces certain outcomes. When will be termed as a random experiment? If the outcomes are not in your control, then it will be called as a random experiment. These outcomes are also known as events as such guys. I said you can divide them into simple events guys or compound events. Yeah, if they cannot be decomposed further as such guys, they are simple events. If they can be decomposed further as such, but they will be compound events. Mutually exclusive events guys are those better where the occurrence of one event automatically excludes the occurrence of the other event. Mutually exhaustive guys, these events cover all the possible outcomes, all the possible scenarios guys. Any one has to compulsorily occur. So agar mutually exclusive hai, A intersection B ka probability will be 0. If it is mutually exhaustive, A union B ka probability will be equal to 1. Then we did equally likely guys or equiprobable guys events. Symmetric events. What are these events? Same chance of occurrence. The probabilities are same. The first definition that we did as such guys was classical definition. Classical definition guys is basically better where the probability of an event will be equal to favorable outcomes divided by total outcomes. If you are able to divide all the outcomes guys into a number of groups which are mutually exclusive, exhaustive and equally likely, then it will be number of mutually exclusive, exhaustive and equally likely groups divided by total number of equally likely, exclusive and exhaustive groups. For you to use this definition, you should have a prior knowledge of all the possible outcomes. Hence, it is also known as the priori definition. Yaad hai nahi hai guys? You should have a knowledge of all the outcomes. This definition can be used only when the total number of outcomes is a finite value. If it is infinite value, we will not be able to use classical definition guys in order to arrive at probability. Yaad aa raha hai kuch? This is where guys we've also defined what is impossible event, what is a sure event. If probability of a specific event as such, guys, is equal to 1, it will be termed as a sure event. If probability of an event is equal to 0, impossible event. Probability of A complement matlab beta non-occurrence of event A. It will be 1 minus probability of A. Odds in favor, हाँ कुछ हुआ मतलब हाँ. Odds in favor, guys, and odds against beta. Odds in favor का definition is favorable outcomes divided by unfavorable outcomes. Odds against beta is unfavorable outcomes divided by. So if probability of A beta, let's say, is 3 by 10, that means out of 10 outcomes, 3 are in favor. How many are against? 7 are against. So odds in favor of A will be 3:7. Odds against A will be 7:3. Are we clear about this? After that, beta, we moved on to statistical definition of probability. Statistical definition of probability. First thing that I told you to remember here, beta, is the concept of relative frequency. Remember relative frequency? Relative frequency is frequency of a particular class interval divided by sum total of all frequencies. So if you would want to know what is the probability that a value selected at random will belong to a specific class interval, frequency of that class interval will become favorable outcomes divided by total frequency will become total outcomes. So as per statistical definition, guys, probability is nothing but relative frequency. This is where we also use limiting value. I said if the experiment is conducted infinite number of times as such, guys, you conduct the experiment n times and you're recording how many times did a particular event occur. So that frequency of that event divided by n will become probability. Statistical definition के हिसाब से बेटा, if this n tends to infinity, how are you going to define fa by n is also nothing but your probability. याद रखना जरूरी है. As per statistical definition as such, guys, it is the limiting value of ratio of fa to n as n tends to infinity. The drawback of classical definition beta was that it cannot be used when the total number of outcomes are infinite. Here I can use even if the total number of outcomes are infinite because you're going to use the concept of limits. Are we clear about this? So यहाँ पे बेटा, in order to arrive at probability, you write Na by Ns. Na by Ns क्या है? Number of outcomes favorable to A divided by the total number of outcomes, that is the total number of events, guys, in the universal set. We also did, guys, different concepts here. How to compute A union B whole complement, how to compute A intersection B whole. If it is A union B whole complement, it can be written as either 1 minus P of A union B, or it can also be written as probability of A complement intersection B complement. Likewise, if it is A intersection B whole complement, either 1 minus P of A intersection B, or probability of A complement union B complement. Whenever it is whole complement, you remove that whole complement, intersection will become union, union will become intersection. Probability of only A अगर पूछा तो either probability of A minus B or probability of A minus A intersection B. याद आ रहा नहीं आ रहा है बेटा? If there are 3 events as such, guys, and they ask us to compute probability of only A. If the events are independent, we will go by A intersection B complement intersection C complement. The best way. A intersection B complement intersection C. वैसे बेटा, if there are 2 events, you can always write A intersection B complement. If there are 3 events, you can write A intersection B complement intersection C complement. Or you can also write, guys, from A, remove A intersection B, remove A intersection C, and add A intersection B intersection C. You recalling this better? 3 events hai. From A, we are removing A intersection B, we are removing A intersection C. But are you not removing this part twice? That is why you add it once. Add A intersection B intersection C. That is how you compute P of only A. Okay. After that, beta, if the 2 events are mutually exhaustive as such, guys, obviously I told you before, probability of A union B will be equal to 1. If there are 3 events which are mutually exhaustive, probability of A union B union C will be equal to 1. If 3 events are both mutually exhaustive and exclusive, 1 is equal to P of A plus P of B plus P of C. आगे का नहीं आएगा. Why won't it come? They are mutually exclusive. If they are exclusive, will all the intersections be equal to 0? Yes. If they are equally likely exclusive and exhaustive, Very good. P of A will be 1 by 3, P of B will be 1 by 3, P of C will be 1 by 3. We moved on to the concept of compound or joint probability beta after this. Compound probability is nothing but the probability of two or more events occurring simultaneously. Joint conditional probability beta is the probability of occurrence of one event given that another event has already occurred. If they ask me to compute P of A given B, you're supposed to write P of A intersection B divided by P of B. Now, P of A given B, guys, will be equal to P of A if the events are independent. If A and B are not related to each other as such, guys, it doesn't matter whether B has occurred or not. Probability of A will not change by the fact that B has occurred or not. Are we clear about this, guys? What is the probability that you will score 90 plus in mathematics given that beta Shubman Gill has scored a double century in the fourth test? Independent events. It should not impact. It should not be like मैं ज़्यादा खुश हो गया था बल्कि ज़्यादा पढ़ा इसीलिए I got more marks. Are we clear about this? So using this only beta, we have arrived at another formula, that is P of A intersection B will be equal to P of A into, this is possible if and only if the events are independent. If the events are dependent, you cannot write P of A intersection B as P of A into P of B. Also remember, if the events are mutually exclusive, they cannot be independent. Exclusive का मतलब ही वही है बेटा, that occurrence of one will automatically exclude the occurrence of the other. If one occurs, the other cannot occur, matlab they are dependent. They are not independent. Are we clear about this? For two events to be independent as such, guys, A and B will be independent, A and B complement, A complement and B, guys, and then A complement and B complement. Any combination thereof as such beta will be independent. Three events agar hai and they ask us the total number of conditions for independence. A and B should be independent of each other. A and C, B and C, A, B and C. Four conditions. ये MCQ में था बेटा. Three events independent रहने के लिए how many conditions should be checked बोल के? The answer is 4. Are we clear about this? Then beta we moved on to probability function. Probability distribution as such, guys, is nothing but you plotting probabilities against different values of x. If this probability can be expressed in the form of a mathematical function, that mathematical function will be termed as your probability function. Are we clear? That is f of small x is equal to capital X is equal to small x. F of small x should be equal to probability of capital X. Capital X beta is a variable under consideration. How many times do you want that variable to occur? Will be equal to small x, number of successes. If this probability function, guys, is in respect of a discrete variable, you call it as a probability mass function. If it is in respect of a continuous variable, you will call it as a probability density function. For probability mass function, probabilities are computed at different points of x. For probability density function, probabilities are computed for range of values. Why do we compute for range of values, guys? We compute, guys, for range of values as such beta because probability at a specific point will always be equal to 0. After this beta, we moved on to the concept of expected value. Expected value matlab computing mean, but mean can be computed for any value. It can be for x, it can be for x square, it can be for x cube. So expectation of x is multiplying different values of x with the corresponding probabilities. Expectation of x square will be multiplying x square values with different probabilities. Are we clear, guys? This is where we also derived variance of x in terms of expectation. Two ways, guys. याद आ रहा नहीं आ रहा है? Variance of x beta can either be written as e of x minus mu whole square or e of x square minus. Very good, guys. This is how you compute variance. If they give us variance of x and ask us to compute variance of y, let's say beta that they give us y is equal to 2 plus 3x and they tell us beta that variance of x is equal to 9. What will be variance of y, guys? 20. Exactly what I did not ask you to do, guys. Variance will be 3 square into 9. 9, 81. Guys, standard deviation of y is mod b into standard deviation of x. Variance of y beta is b square into, mat karo yaar, 1000 baar bola that this is a common mistake. That mod b multiplied by standard deviation of x is a rule that is applied only to standard deviation, not to variance. Are we very clear about this? So We can compute variance as such guys using expected value as well. समझ में आ गया बच्चों सबको? Now guys, moving on to the next part beta, that is theoretical distribution. So under theoretical distribution as such beta, we first did the fact guys that these are all what? Distributions that exist in theory as such beta, because if you actually observe frequency distribution, then distribution as such beta as per this probability functions. If you are computing frequencies as per a probability function, it may or may not match with observed frequency distribution. What is observed frequency distribution? You are actually conducting the experiment multiple times and you're noting down guys the frequencies of the different values of x. So under theoretical distribution functions guys, we did three important theoretical distributions. Two for discrete variable, one for continuous variable. For discrete variable guys, we have binomial distribution and Poisson distribution, and for continuous variable we have normal distribution. Now the things that you're supposed to remember in relation to binomial distribution. First important thing, binomial distribution guys is applicable if and only if the outcomes of the experiment as such guys can be divided into two categories which should be kya beta? Mutually exclusive. Are we clear about this guys? Mutually exclusive and exhaustive. They need not be equally likely, but they should be mutually exclusive and exhaustive. You should be able to divide them. The trials, that is the number of times you're conducting the experiment as such guys, should be independent. Matlab the probability guys should not change irrespective of the number of times you are conducting the experiment. Are we clear? So the number of times you conduct the experiment is referred to as n. The probability of you succeeding when the experiment is repeated once is denoted by p. The probability of someone not succeeding will be referred to as q. So that is why we say that binomial distribution is biparametric. There are two parameters that are required to construct a binomial distribution. One is n, the other one is p. N stands for the number of times you're repeating the experiment. P is the probability of success. Your discrete function here beta is ncx into p power x into q power n minus x. This is how you will be determining the probability of the number of successes. If you're repeating the experiment 10 times, the number of successes will range from 0 to 10. It will obviously be a whole number guys, integer. It cannot be a fractional number. Are we clear? The number of successes cannot be 0.5, cannot be 1.5. This is not a continuous variable. This is a discrete variable. What's the doubt, Tanesh? You use binomial distribution only when the total number of trials are finite. It should be a limited finite value. Now, mean of a binomial distribution will be equal to n into p, standard deviation root over npq, variance will be equal to npq. Mode will depend on the value of n plus 1 into p. If n plus 1 into p is an integer, there will be two modes. One is n plus 1 into p, the other one is n plus 1 into p minus 1. If n plus 1 into p is a non-integer, there will only be one mode, and that will be integral value of n plus 1 into p. Variance will be maximum guys when p is equal to 1 by 2, q is equal to 1 by 2, and the value of that variance will be equal to n by 4. If x follows binomial distribution of n1 and p, y follows binomial distribution of n2 and p, x plus y will follow binomial distribution of. Just add the number of trials of both the experiments. Do not add the probability of success. I gave you an example of I'm tossing a coin 10 times, I'm tossing a coin 6 times. If I add both of them as such beta, the probability of head cannot change. It is just that I'm conducting the experiment 16 times. Are we clear? You only add the number of trials. Do not add probability of success. Now, binomial distribution guys can be zero symmetry, that is beta zero skewness. And then beta it can have a positive skewness, it can have a negative skewness. It will be symmetrical guys, that is perfectly bell shaped when p is equal to, excellent, p equals 1 by 2, q equals 1 by 2. It will have positive skewness when p is less than 1 by 2. कैसे याद रखोगे? P for Poisson, P for positive skewness. Poisson is always and always positively skewed, and Poisson with the probability of success will be very, very less. Obviously, when I say very, very less, will it be more than 1 by 2 or less than 1 by 2? So when p is less than 1 by 2 as such beta, Poisson distribution and binomial distribution will have similar skewness. पॉजिटिव स्क्यूनेस का मतलब होता है पीक कम्स फर्स्ट, दैट इज मोड कम्स फर्स्ट फॉलोड बाय मीन. दिस इज व्हाई द डिफरेंस बिटवीन मीन एंड मोड इज पॉजिटिव. Are we clear? The tail will be extended to the right side or the left side? So positive skewness is right skewness. When P is more than 1 by 2 as such beta, the concentration of values would be higher towards the later part. That is why guys, mean comes first followed by peak which is mode. उसको क्या बोलते हैं? Negative skewness. Proud of you. So for binomial distribution anything is possible. It is symmetrical only when P is equal to 1 by 2. After that beta we moved on to Poisson distribution. उसमें भी बेटा पूरे अकाउंटिंग स्टैंडर्ड्स पढ़ा रहा हूँ, नॉन स्टॉप 4 घंटे बात करना पड़ता. So Poisson distribution as such guys is applicable as such beta where the number of trials tends to be an infinite value and the probability of success is a very small value. N tends to infinity, P tends to 0 such that the product N into P is still a finite positive value. I gave the examples of number of vehicles flying on a road will be very large, but the probability of a particular vehicle meeting with an accident will be very, very less. But there will still be some accidents as such guys that are happening. So the product of N into P is still a finite positive value. The number of parts in an aircraft and the number of defects, again Poisson distribution. The number of words printed in a book and the number of misprints, again an example of Poisson distribution. ठीक है? Now, for Poisson distribution, guys, all you have to do beta is compute the value of M. It is uniparametric. Uniparametric matlab only one parameter, and that is M. M is nothing but the mean, average value, which will be computed by writing N into P. Once you know M, guys, the probability function for Poisson distribution will be e power minus M into M power X by X factorial. Unlike binomial distribution where the total number of successes will end with some value, Poisson distribution mein beta X starts from 0, goes up to infinity. X will be 0, 1, 2, 3, 4, so on till infinity. Because the number of trials, isn't that an infinite value? Yes or no guys? Even here probability cannot be computed for decimal values. If they ask you to compute the probability that the value of X will be between 1.5 to 1.8, not possible. 0. Between 1.5 to 1.8 nahi reh sakta. It can either be 1 or it can be 2. If they say between 1.5 and 2.5, you compute probability of X equals 2. So the probability function is e power minus M into M power X into divided by X factorial. Mean here will be equal to M, variance is equal to M, standard deviation is equal to root M. The mode will depend on the value of M. If M is an integer, there will be two modes, M and M minus 1. If M is a non-integer, only one mode, and that is the integral value of M. So if M is equal to 1.2, what will be the mode? If M is equal to 2, 2 and 1, both of them will be modes. Even under Poisson distribution guys, we have additive property. If X follows Poisson distribution of M1, Y follows Poisson distribution of M2 guys. X plus Y will follow Poisson distribution of M1 plus M2. Poisson distribution guys can never be symmetrical obviously. It will always and always have positive skewness. But the peak comes first and then followed by mean. Are we clear about this? Positive skewness is also known as right skewness beta does not depend on where are the values concentrated. The word right or left depends on where is the tail extended. Are we clear guys? Next beta, the last distribution here without yawning is normal distribution. नहीं तेरे को थोड़ी बोला बेटा, तू मच्छर खा रहा था ना. Normal distribution as such guys is applicable for a continuous variable. Now normal distribution is symmetrical about its mean. Meaning guys, mean divides the entire set of observations into two equal parts. The number of values less than mean will be 50%. The number of values more than mean will also be 50%. So the probability that the value will be less than mean beta tarang. जोर से बोलिए sir. The probability beta that the value will be less than mean will be 50%. The probability that the value beta will be more than mean is also 50%. Because mean is dividing all the set of observations into two equal parts as such guys, mean also will be equal to median. And because the peak occurs at this point, it will also be equal to mode. So mean equals median equals mode. The first thing that we have learned guys under normal distribution is how to compute probabilities. There are two parameters that are required. One is mean, the other one is variance, standard deviation. In order to compute probability guys, you will have to measure the distance between mean and a specific point in terms of standard deviation. उसको बोलते हैं Z score. याद आया कुछ? Z is equal to X minus mu divided by standard deviation. Believe me guys, even if there are two questions from normal distribution, one of them will be directly based on those properties. What is quartile 1, what is quartile 3, what is mean deviation. Direct application of formula, dead easy to score in the examination. So, यहाँ पे बेटा you'll have to compute Z score. Based on this Z score, you will have to compute the probability. ठीक है? जैसे mean minus 1 time of standard deviation, mean plus 1 time of standard deviation covers 68.26% of the area. 0.3413 is the area against a Z score of 1. So there will be 34.13% of the values to the right side of the mean, 34.13% of the values to the left side of the mean. Likewise, beta, mean minus 2 standard deviation to mean plus 2 standard deviation covers 95.44% of the area. Mean minus 3 standard deviation to mean plus 3 standard deviation, 99.73, all but 0.27% of the area, 99.73. Mean minus 1.96 standard deviation to mean plus 1.96 standard deviation, 95. But mean minus 2, mean plus 2 is 95.44, little less than 2, 95%. Are we clear? It covers 95% of the area. So under normal distribution, in order to compute quartile 1, you will have to write mean minus 0.675 standard deviation. We have calculated this better. Indirectly, it means a Z score of 0.675 covers 25% of the area. So to compute quartile 3, you will write mean plus 0.675 standard deviation. Quartile deviation will be equal to 0.675 standard deviation. Mean deviation will be equal to 0.8 standard deviation. They can also ask like this: quartile deviation is approximately equal to 2/3 of standard deviation. याद आया? 2/3 is 0.667 better, but theory question में ऐसा आ चुका है exam में, that is why you should remember. Points of inflection, guys, this is where the curvature of the normal curve changes. Convex becomes concave, concave becomes convex. So points of inflection will be mu minus standard deviation and mu plus standard deviation. You have learned about computing cumulative area phi of x, guys, but this will always be in terms of Z score. याद है नहीं है? So when you say cumulative area, it is from negative infinity to a specific point. जब भी they ask us to compute probability, guys, by giving cumulative area or one tail area. Remember one tail? One tail area, beta, is from that point to the tail. It can be left tail or it can be right tail. Immediately draw a graph. Once you draw a graph, you'll automatically know, beta, what is the area that is given or what is the area that you have to compute. Is that clear? The probability function, guys, under normal distribution is 1 divided by standard deviation into root over 2 pi into e power minus of x minus mu whole square divided by 2 times of variance. ये formula, beta, we did not use to compute probability. We have used this formula only and only to identify what is mean and standard deviation. इसका definite integration किए तो बेटा you will be able to compute probability. जो Z scores आते हैं, it is all based on definite integration of this. After that, beta, we also did standard normal area. याद है standard normal area? If you have converted all the x values in terms of Z score, guys, you should be using the word standard normal variable. So if they use the word standard normal variable in the question, it means mean is 0, standard deviation is 1. So all the values, beta, will correspondingly change. అర్థమవుతుందా లేదా? Mean will be 1, standard deviation, beta, mean will be 0, standard deviation will be 1. So what will be your quartile 1? Negative 0.675. What will be quartile 3? Positive 0.675. Quartile deviation 0.675. Mean deviation 0.8. Points of inflection -1 and +1. Like how we have additive property, guys, under the other two we have additive property here also, guys. For this you'll have to add means and you have to add variances. Do not add standard deviation. Are we clear? You want to compute standard deviation, first add variances, guys, and then take the root of that combined variance. You will automatically get standard deviation. ये भी एग्जाम में आ चुका है, समझ में आ रहा है नहीं आ रहा? ये तो लास्ट वाला पार्ट है बेटा, ये है नहीं, बीच में बहुत पहले एक बार एग्जाम में आया था, हाउ टू कंप्यूट थर्ड मोमेंट, हाउ टू कंप्यूट फोर्थ मोमेंट. वी ओनली हैव फर्स्ट मोमेंट एंड सेकंड मोमेंट. फर्स्ट मोमेंट को बोलते हैं मीन, सेकंड मोमेंट को बोलते हैं वेरिएंस. वी लर्न हाउ टू कंप्यूट मीन एंड वेरिएंस अंडर बाइनोमियल, पॉइसन डिस्ट्रीब्यूशन एंड Poisson normal distribution. Third moment is called as skewness, guys. Skewness का formula is different as such बेटा, but then वो पहले एक बार मैं उनको देता था क्योंकि बहुत पहले it came in the examination. That is why I used to discuss. But lately as such, guys, it has disappeared. It doesn't come anywhere in the examination. Alright, so you can ignore third moment and fourth moment, not required. Are we clear? So that's the end of theoretical distributions. और क्या बचा सर? अभी थोड़ी पीछा छोड़ूंगा बेटा. Online students will now revise sampling. Alright guys, the last topic but under statistics, sampling. नहीं यार हो जाएगा 2 मिनट क्या कल बेटा. So complete enumeration as such guys is called as census. Now not always as such better the population will be in existence. The example of lamps manufactured by a company as such guys, few of the lamps may not be in existence now. Also guys, it may not be always viable better to verify the entire population because of time and cost constraints. This is where better we resort to sampling. Under sampling, we draw a random sample to infer about an unknown universe. Okay? There are 4 principles of sampling. Beta, शक्ल सीधी करोगे तो मालूम पड़ेगा कि 4 principles है. The first one, guys, is law of statistical regularity. Law of statistical regularity states, guys, that if you draw a fairly large sample randomly, then it would possess all the characteristics of the population on an average. Very good. The next one is principle of inertia. Principle of inertia says as you keep increasing the sample size, reliability and accuracy will keep increasing. Finally, we are participating. The third one is principle of optimization. Principle of optimization बोलता है बेटा, either decide an amount of cost, and that cost you'll have to perform the task with the highest efficiency, or decide upon a level of efficiency, guys. For that efficiency level, perform the task at the least possible cost. The last one beta is principle of validity. You should be able to estimate the population parameter, and not just that, you should also be able to check whether the parameter that has been computed as such, guys, is reliable or not. Now this is possible if the sample drawn is based on simple random sampling. Then we did the comparison of sample survey and complete enumeration. In terms of speed, guys, in terms, so whenever you're going to listen to this, so that was Rushil. अरे तू एक मुस्कुराहट लाएगा बेटा उनके चेहरों पे. So when you talk about speed as such, guys, it is sampling as such better that can be performed faster as such, guys, in comparison to complete enumeration. When it comes to cost, guys, total cost will be lesser in terms of sampling. However, the cost per unit will be higher in respect of sampling. Then there is reliability and accuracy. Reliability के मामले में sampling wins. Accuracy के मामले में population, complete enumeration wins. Reliability of the data beta that you have collected will be more because in respect of sampling, because there are experienced enumerators who are collecting the data. Complete enumeration obviously will result in more accurate answer as such, guys, because all the observations are being verified. Are we clear? The last point as such beta was necessity. If the population is no longer in existence as such, guys, then obviously you will have to resort to sampling. And if it is mandatory as such beta or important that you verify all the observations under consideration, then you cannot resort to sampling. You will have to do complete enumeration. When government collects data, guys, it has to be complete enumeration and not sampling. और एक example जो materials में दिया हुआ था बेटा, aircraft. Inspection cannot be on a sample basis. It has to be better a complete enumeration. Then guys, as far as errors are concerned, we have divided errors, guys, into 2 categories. One that arise only under sampling. The others that arise whether it is complete enumeration or sampling. Under sampling errors, there are 5 categories. The first one is faulty sampling design. The way you're selecting the observations, if it is incorrect, but obviously the results will not be reliable. This can be eliminated by selecting a sample randomly. Simple random sampling as such beta will remove this defect. Next beta is error due to substitution. Shresht aaya pheka wapis. Yaad hai beta? So error due to substitution, guys, is wherein an observation, guys, is being replaced with an other observation. Faulty demarcation of units is you underestimating or overestimating the variable under consideration. Wrong choice of statistic. In order to estimate population mean, you're computing median of a sample. Are we clear, guys? Variation. If the population as such beta has huge amount of variation and you're selecting sample randomly beta, then the results might not be accurate. Non-sampling errors as such, guys, your intelligence as such beta or anything of that sort can result in non-sampling errors. It can be error in copying data, miscommunication, guys, lack of judgment. Are we clear? Then, guys, we spoke about the terms relevant to sampling. Population can be finite or infinite. Population of roses in Lake Salt City will be infinite population. Population of mosquitoes in India will be. But ये example was there in statistical description of data. I gave India का example, but I think they mentioned Kolkata. ठीक है? Are we clear about this? नहीं बेटा बच गया. Next, guys, anyways, population can also be existent or hypothetical. Hypothetical population beta is a population that exists only in theory as such, guys. Coin tossing, roll dice karna, dice roll karna beta. All right. Now, as far as the size is concerned, relax beta. As far as the size is concerned as such, guys, population ka size is referred to by capital letter N. Sample size beta is referred by small letter n. The characteristic of the population is called as parameter. For sample, it is called as statistic. Parameter is represented by theta. Sample beta, it is capital letter T, guys. Mean of population mu, sample x bar. Standard deviation of population sigma of sample small s. Proportion of population capital P. Proportion of population sample beta small p. Now, whenever we are drawing samples as such, guys, of a fixed size n, if it is with replacement, the total number of samples will be capital N to the power small n. And if it is without replacement, guys, it will be capital N C small n. Now, every time you pick up a sample, guys, and compute a statistic value, which can either be sample mean or sample standard deviation or proportion, the value can differ. This difference in the values of statistics, guys, of different value of a statistic beta of different samples will be called as sampling fluctuation. If you multiply all of the statistic values by the corresponding probabilities, that will be called as the expectation of statistic. If you compute standard deviation of the different values of statistic, it will be called as standard error. So we can compute expectation of sample mean, we can compute standard error of sample mean, we can compute expectation of sample standard deviations or standard error of sample standard deviation. That is one way of computing standard error. The other way of computing standard error, guys, for sample means is population standard deviation divided by root n. This is if the samples are drawn with replacement. If it is without replacement, you will have to multiply by finite population correction factor, which is root over capital N minus small n divided by capital N minus 1. This can be ignored as such, guys, if the population is very, very large, tends to infinity, because the value of capital N minus small n by capital N minus 1 will tend to 1. Same way, beta, if you're computing standard error of proportion, it is root over PQ by N and then multiply by finite population correction factor. Are we clear about this? Standard error का definition मालूम रहना चाहिए, alternative formula मालूम रहना चाहिए. So standard error is standard deviation of all the statistic values. And then directly, if you would want to compute standard error of mean, it is population standard deviation divided by root of sample size. After that, as such beta, we directly moved on to the types of sampling. Under types of sampling, we have three broad categories. देखो वहां पे देखो, मैं देख रहा हूं ना. We have three categories, guys: probabilistic, non-probabilistic, and mixed sampling. Under probabilistic sampling, as such beta, we have simple random sampling, stratified sampling, multi-stage sampling. Simple random sampling is where all the observations as such, guys, have an equal chance of being selected. It can be with replacement or without replacement. Now, with replacement, without replacement will not make any difference if the population is very large. You use simple random sampling when the population is not very large, the sample size is not very small, and the population is not heterogeneous. It should not be heterogeneous. If the population is heterogeneous, we move to stratified sampling. Under stratified sampling, the entire population beta is segregated into different groups or stratas. So within each group as such beta, there will not be any heterogeneity, lesser heterogeneity. Between each group, if you compare one group with another group as such, beta, there will be heterogeneity. What you do, beta, is you pick up a sample from each group, and using that sample as such, beta, you will estimate the population parameter. Advantage, you will have a parameter for each group as well as an overall parameter. There's a proper representation of every group. Are we clear? Here to compute sample size, beta, we have Bowley's allocation and Niemann's allocation. Bowley's allocation bolta hai that sample size should be directly proportional to population size. Here population size is population of the strata. Niemann's allocation says that a sample size should be proportional to both population size as well as population standard deviation. Are we clear about this? Again, this method beta will be more accurate because there's a proper representation of all the groups. After this, we moved on to multi-stage sampling. I said multi-stage sampling is normally preferred when the population consists of first stage sampling units, second stage sampling units, third stage sampling units, and so on. So you first select few first stage sampling units randomly. Under that, you again select few second stage sampling units randomly. Again, that under that beta, you'll select third stage sampling units and so on. Advantage, basically different geographical locations. Advantage, it adds flexibility, wider coverage, lesser cost as such, guys. But then disadvantage, the results will not be accurate. Not as accurate as stratified sampling. Are we clear? Then beta, we moved on to mixed sampling, which is systematic sampling. Under systematic sampling as such, beta, you first decide on a sample size, divide the entire population size by that sample size, and if the result, say for example 20, you select one observation randomly from the first 20 observations, and thereafter beta keep selecting from every 20th observation. If you have a perfect multiple beta like this, n is equal to nk, then it will be termed as linear systematic sampling. If it is not a perfect multiple, it will be circular systematic sampling. The biggest drawback of systematic sampling beta is that if there is a hidden trend as such, guys, and your sample is based on that trend as such beta, then it will not depict the population under any circumstances. Are we clear? Plus also you will not be able to perform any test because it is not a pure probabilistic sampling design. The last wala beta is purposive or judgmental sampling as such, guys. This is where it is not based on the bias of the person as such, guys, who's selecting the sample. Are we all clear about this? That's the end of sampling as well, beta. Online students, break time.